Hello everyone, welcome back to EduMoon tutorials. My name is Srinitya and I'm going to be teaching engineering drawing. Now we are in unit 6, that is in this video we're starting unit 6. It is solids, projection of solids. The subtopics are introduction, what are solids, and projection of solids. Basically we'll solve some questions in projection of solids. So in this chapter I'll just introduce the topic. So let's begin. Introduction. So we all know what solids are. Solids are three-dimensional objects, that is they have three dimensions. Example, they can have length, breadth, height, etc. Some examples are cube, cuboid, cone, prism, pyramids, cylinders, sphere, etc. So we must have already studied about these in our mathematics. We might have studied how to calculate the surface area, the volume, etc. of these solids. So now we're going to take a look at these solids, and we're going to try to draw the orthographic projections of these solids. So if you remember in my previous videos, I said different views of the object are obtained. Till now we only saw points, a line, and planes. So in solids, the object that is placed is going to be a solid, and we're going to look at it in different views, and we're going to try to understand the object better. So there are many solids that we'll be looking at. So we all know cube, it's the three-dimensional figure of a square. Cuboid, three-dimensional figure of a rectangle. Sphere, 3D for a circle. Next we have polyhedra. Polyhedra is basically solids that are bound by plane surfaces. For example, prisms and pyramids. So prisms, you have a square prism, a triangle prism, a hexagonal prism, a pentagonal prism, and a rectangular prism. So these are the different prisms. Next we have pyramids. Same, triangular prism, triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. So here all the faces, all the sides except the shape are going to be triangular, and they'll meet at one point called the apex or apex. Then we have the solids of revolution, that is the cone, cylinder, and sphere. So next, let us take a look at frustums. So what are frustums? When a section plane cuts the solid either parallel to or inclined to the plane, the remaining solid is called a frustum. So basically, we've discussed so many solids like this prisms or pyramids. So let us say somebody cut them in half, or maybe somebody cut them inclined to some angle. So the remaining portion is going to be is called the frustum. So example, let us say we have a square pyramid and somebody has cut this part. So the plane that is used for cutting is called the section plane. We'll know more about the section planes in the next chapter, that is sectioning of solids. Anyways, so after the solid is cut, the remaining portion will look something like this, and this is called the frustum. Now one thing to remember in these questions is solids have axes. I'm sure all of you know this. So now in the questions, the position of the solid is going to be given with respect to the axis. So the question may say the axis of the solid is inclined 30 degrees to HP, let's say. So that means the solid is inclined 30 degrees to HP. So all the positioning dimensions will be given mostly with respect to the axis. So it's very important. If you remember in the first unit, we discussed how to draw the axis. You have to draw the axis using a 2H or a 3H pencil, that is 6 mm line, 1 mm gap, 2 mm line, 1 mm gap, 6 mm line, 1 mm gap, and so on. So this is just a table that I've created, very similar to the reference table that we used in for projection of planes. So again, here we have so many different types of questions because there are so many different types of solids and different cases that can occur. So here I just made the table, so you can use this for reference when you're solving questions. So you can screenshot it if you like. So the position of solid, if the axis is perpendicular to HP, then we start with the top view and there's only one number of steps. If the axis is perpendicular to VP, we start with the front view. Number of steps is 1. The axis is perpendicular to the projection plane and axis is parallel to both HP and VP, then we start with the side view. So basically we start with this view. So you have to start with the view in which you can see the shape of the object. That is, this is a square pyramid. Sorry, this is a square prism. So you have to start with the view in which you can see the square. So for this you have to start with the view in which you can see the hexagon. So that's what they're trying to say here. Axis parallel to VP, inclined to HP at an angle theta. Assume axis is perpendicular to HP. Redraw the front view as inclined view. This is similar to when first we assume that the plane is parallel to VP, then we incline it. So similarly, first we'll assume that the solid is perpendicular, then we'll incline it. Similarly, if the axis is parallel to HP and inclined to, so there are two steps here. Inclined to VP at theta degrees. So first we'll assume that the axis is perpendicular to VP and then we can incline it. So in this video we just discussed the introduction of projection of solids. We took a look at what are solids and different examples for solids. And in the next video we will try to solve some questions on projection of solids. Thank you for watching.